All right, so we're just finishing up chapter 4 here, and then we're going to start chapter 5. So we didn't cover types of variables. So what is a variable? It's just a characteristic that varies. For example, your responses to survey questions are variables because it varies from person to person. So variables fall into two types. They can either be quantitative variables here, and those are variables that are described numerically, for example, questions that you answered with a number. And then there's qualitative or categorical variables that would be on our survey questions you answered with a category, like what gender are you? So quantitative variables can be further broken down into two types, continuous ones and discrete ones. And continuous ones would be things like height or time, temperature, etc., that between any 2 points you could break it down further. You could actually break it down into an infinite number of points. So it's completely continuous. There's no breaks in it. Whereas discrete variables have breaks or units, like something like family size. Anything that's countable would be discrete. Or pulse rate, you're counting your heartbeats per minute, etc. Now, of course, you can change these continuous variables into discrete ones by rounding. But this is the basic idea. And these can be described best displayed with histograms, as opposed to histograms, ones that are characteristics that are naturally measured numerically, of course, can be displayed best with histograms. Whereas ones that just have categories where there's no meaning to the x-axis in terms of they're just categories, are best displayed by bar graphs. Okay? And what would qualitative or categorical variables be? Things like what gender are you? What's your favorite color? Etc. What's your major? All those survey questions that you answered with a word instead of a number. Now there's some you might answer with a number, like let's say, what if I asked you, what's your social security number? What's your zip code? You answer with a number, but those numbers are just categories. They don't have any quantitative meaning. You know, the bigger the zip code doesn't mean there are more people live there. They don't refer to any quantities. They're just categories. So zip code, social security number, etc. And of course, these we code them numerically, but they're just descriptive categories. The numbers are. Whoops, you can't see that. Sorry. So sorry. There you go. So let's move on. And now we're going to start chapter 5. But before we do, I just want to say a word about these summaries. At the end of each chapter, there's a summary. So on this chapter 4, here's the summary. And rather than going over each point with you, I want you to just read these carefully. So read all summaries carefully, because they sum up everything in the chapter. Read all summaries carefully. Okay, so now we're going to start chapter 5. So let's do that. All right, so chapter 5 is on the normal approximation. It's on the normal curve. So what is this normal curve? Well, this normal curve is an ideal histogram. It's a continuous histogram. And it centered at 0. It's average. It's symmetric around 0. It's centered at 0, so it's average and median are both 0. And its standard deviation is 1. And this horizontal axis here is measured in something called z-scores. And it's a histogram. It's really important for one reason, because so many data sets you are very similar to the normal curve. For example, your height, your weight, IQ. There's many data sets that look like the normal curve. So for these data sets, we can approximate any type of areas under the actual histogram with this idealized normal curve. So the equation for here's the density, or the height. So this is the x-axis here, and we can describe the height with this formula for the normal curve. So the formula is 1 over the square root of 2 pi times e to the minus. Okay, so that you can see that when the z-score is 0, this part's just 1, so you have 1 over the square root of 2 pi, which is about 0.4, and that's the maximum. You can also see from this formula that the curve is going to extend forever in each direction, because x can get as big as possible, and y will then approach 0. The limit will be 0, but it will never reach exactly 0. So this goes on in either direction, to positive infinity and negative infinity. So you're going to see this normal curve not only as an approximation of real data sets, but also as the way to look at the probability distribution of the sample average. If you took the sample average over and over and over again, no matter what population, you took different samples from some population that wasn't normal, and you did that over and over and over again, and looked at what you got, it would be, to a histogram of what you got, it would follow the normal curve. That's called the central limit theorem, and we're going to talk about that later. But for now, we're just on descriptive statistics, so we're going to use this beautiful normal curve to approximate histograms of real data. So now, as we move down, there's this, we're going to be looking at percentages. We're going to look at how to calculate the percentage of area within any interval on this normal curve. So this standard deviation 1, 2, 3 rule comes in really handy. And what it says is that 68% of the data is within 1 standard deviation of the average. About 95% is within 2 standard deviation of the average. And about almost all the data, 99.7%, is within plus or minus 3. So this is the 1, 2, 3 rule. It's also, you might see it as, it's the same as the 3 sigma rule, because sigma's the Greek letter, this is the term for standard deviation. Or you might see it as the 68, 95, and 99.7 rule. So let me see if I can zoom out here. Okay, so this normal curve is really useful to do what's called the normal approximations. And what that is that since many data sets resemble the normal curve, you can translate them into a normal curve. So let's look at this example down here. So the jagged histogram here represents the heights of about 7,000 women, and superimposed upon it is this normal curve. So you can see that it's a fairly good estimation. It sometimes underestimates the actual histogram and sometimes overestimates it, but it's fairly accurate approximation. So if we want to use the normal curve and use our 1, 2, 3 rule and easily look up areas under the normal curve, we have to translate this axis, which is actually in real values, here it's inches, into what we're calling z-scores, standard units, which are z-scores. They have no units. They just tell you how many standard deviations you are above or below average. Okay, so we can do this by first subtracting off the average. And what that will do will change, like if we the average right here is 63.5 and the standard deviation is 2.5, right? It's right here. So we want to change that to 0. So if we subtract the average off all these values, we'll get 0 here. So subtracting the average changes the average to 0, which is what we want to do. And now we're going to, so we'd have, if we subtract the average off, we have 0, then we have 2.5 here, then we have 5, etc. And so now we want to divide by the standard deviation, and that would change, this is 2.5 away, and since 2.5 is the standard deviation, it would change that to 1. So it changes the standard deviation to 1. All right? So let's do that here. So to answer the question of what percentage of women are between 61 and 66 inches tall. So we first have to convert those endpoints to standard units or z-scores, right? So we're just going to follow this right here and say our z-score is equal to our value minus the average divided by this SD. So in this case, it's 66 inches minus 63.5 inches over 2.5 inches, which is 2.5 inches divided by 2.5 inches. And you can see the units cancel out and we just get 1. And what does that mean? So that means we have a z-score of 1, which means what? It means z equals 1 means 1 standard deviation above the average. Okay? So now we can do the same thing with, hold on, I just want to see if this, I want to focus this. All right, now how about 61 inches? We'll do the same thing. So z is equal to 61 minus 63.5 over 2.5, and here we have negative 1. So it lines up with negative 1 here. So what does that mean? So z equals negative 1 means 1 standard deviation below the average. Okay? So the negative here just means below, as you can see. It's symmetrical. All right, so now what if a woman's height has a z-score of 1.2? How tall is she? Okay, so what does z equal 1.2 mean? It means that she's what? It means that she's 1.2 standard deviations above the average. So what is that? That's 1.2 times the standard deviation is 2.5 added to the average, which was 63.5. So what is that? That's 3. So she'd have a height of 66.5 inches. So that's the idea there. And now let's look at this normal table here. And it might not be the same type of table that you're used to because it just displays the middle area here. So it gives you z-scores here between z and negative z. So if we look for our 1, 2, 3 rule here, like the area between negative 1 and 1, according to that 1, 2, 3 rule is 68%, 95%, and 99.7. Well, we can look that up also on this table that rounds those areas to 2 decimal places, so it gives you a little bit more accuracy here. So if we look here and look between 1 and -1, we see that the middle area is actually 68.27, rounded to 2 decimal places instead of rounded to the nearest integer. So this is 68.27%, and we can look here for between 2 and here's, even though it only gives you the positive z's, this is between 2 and -2, so that's 95.45%. Now we rounded here 99, we didn't round to the nearest whole number here between 3 and -3, because look at this. As you get towards the tail, look how many values are at 99. Starting at way up here, look at all these 99s. So that's why we rounded to 1 decimal place. But if we wanted to be a little more accurate, we could look here and see it's between 3 and -3 is 99.73. All right, here's what we didn't do. Between -0.75 and 75, well, we know it's going to be less than 68, so let's see what it is. And it is 54.67. So that's the idea here, and this is the table that you're going to be using that's in your notebooks, and you're going to have provided for you on every one of your exams. Now you can also use other tables, or on our website we have a normal curve calculator where you could calculate where it will give you the area between any 2 values. And then you can use that on your homework, but since you're going to, I think that the reason why I like using this one is because it's very simple, and it helps you to get a good feel for the normal curve and to do a lot of approximations in your head. And it also will help us when we get to confidence intervals. So I think that it's very useful. So we're going to be using this in class, and I strongly recommend that even on your homework you use this. Now sometimes we want more accuracy, and on the homework it will you'll be given instructions about whether to use this normal table or to use a more accurate table, or the p-value calculator, the normal table calculator. All right, so now let's move on and do this normal approximation. And of course, the warning is when histograms don't follow the normal curve, you can't use a normal approximation, right? But if you can use a normal approximation, it's really nice because all you need is the average and the standard deviation. Like an average, here's a list of weights, follows the normal curve. And all you need to know is an average and a standard deviation. And with those two statistics, you can figure out the percentage of data that falls within any interval just by using the normal table. So let's try this. And so, for example, if you want to find out what percentage of the people weigh less than 120 pounds, so what do? Well, the first thing you have to do is change to z-scores. So let's say that. Let's write that down. So convert 120 pounds, right, to a z-score. So let's do that. So we'll just say z equals the value, which is 120, minus 150 over 20. And we get negative 1.5. That's the z-score. So now what do we want to do? Now we want to mark that on here. So we're going to mark the z-score on the curve and shade the area that you're interested in. All right, so let's do this. Remember the normal curve here. It's centered at 0, 1, 2, 3, negative 1, negative 2, and negative 3. So we have negative 1.5. So where is that going to fall? right here. Let's add n. So that's z equals negative 1.5. All right, and what's our area of interest here? Well, we look up here and it says way less. So this is we're trying to figure out the percent of the people that weigh less right here and have a z-score less than negative 1.5. So now this is where we have to use the normal curve. So we'll use the normal curve to find that area. So the normal curve gives us the area between z and negative z. So we have to get this middle area right here between negative 1.5 and z equals positive 1.5, and then figure out what that area is on the table. So we'll do that. So that's 1.5. It's 86.64%. So that's 86.64%. Now let's just round to 87. And unless I tell you otherwise, you can do that. So 87% is in the middle. And remember that the entire curve has an area of 100%. So that means that these two tails together have to be 100 minus 87, 13. So they're symmetrical, so they're each 6.5%. So our area that we're interested in, that tail, is equal to 100 minus 87 divided by 2. Now let's just make sure that, let's look at how this makes complete sense. So here's our z-score here, and here's our values, pounds. Now right in the middle, our average is 150. And our standard deviation was 20. So if we go down one standard deviation, that would be down 20 pounds. That would be 130. And then another half would be another 10 pounds. And that's where 120 lines up here. All right, now let's suppose we want to find not just a tail, but an interval, like an interval between 120 and 160. So between 120 and somewhere here. Now what would we do then? All right, we're going to have to convert. You always have to convert these values to z-scores. That's your very first thing to do. You have to do. We already did this one. Z equals negative 1.5. And now let's do this one. So z equals 160 minus 150, we're 10 pounds above. And in terms of standard units, since our standard deviation is 20, that gives us 0.5. So now we've got these two z-scores, and let's draw them here. All right, so here's 0, 1, whoops. 1, 2, and 3, negative 1, negative 2, and negative 3. And what do we have here? So this is right here. This is z equal to negative 1.5. And now we can draw in right here z equal to positive 0.5. So this is what corresponds to, let me draw this other axis here. This is the z, and this is the pounds. So this is where we have 160, and this one was 120. And of course, okay, so we're trying to find that area there. So what do we know so far? Well, we know, here, let's just divide this like that, right? And this is 150 pounds, right in the middle. All right, so we know that there's 87% between negative 1.5 and 1.5. Well, we just want half of that. So this area right here is going to be 87 divided by 2. So everybody see that? It's 87, the whole thing. So we just want half of that, so that's 87 divided by 2. And now we just want that little piece, this piece. Well, what's that going to be? Well, we have to use the normal table, and the normal table is always going to give us a middle area. It will give us the middle area between 0.5 and negative 0.5, so we'll just take half of that. So let's see what that is. So right here, z equals 0.5 gives us 38.29. Let's just round that to 38. So that's 38 divided by 2 right there. So our area is equal to 87 divided by 2 plus 38 divided by 2. That's 125 divided by 2, or 62.5%. All right, so now, boy, I've got out of focus again. All right, so let's look at this example. According to our survey data, the histogram for the fastest speed ever driven is close to the normal curve with an average of 90 after I excluded the people who never drove. So these are for people in the class who've driven. The average was 90 and the standard deviation was about 24. So the question is, what percent of the class, 95% of the class, listed fastest speeds between what and what? Just given these two pieces of information and that the data was close to the normal curve. Well, this 95%, that's the 2, or the 1, 2, 3 rule. So we should know that. So between what? -2 and 2 lies 95% of the data. So when I ask this on exam, people just say, okay, 95% of the class listed fastest speeds between 2 and -2. But we're talking about miles per hour, right? So what is this -2 and 2? That tells you how many standard deviations you are above the average, which is 90. So our lower limit would be 90 minus 2 standard deviations, which is 24, is 1 standard deviation. And our upper limit, a z-score of 2, would translate into what? 90 plus not 2 miles per hour, but 90 plus 2 standard deviations. And each one of these standard deviations is 24. So that's 90 plus 48. So that gives us 138 and 42. All right, now I advise you at this point, and I do this a lot, to stop the video and try what I'm going to do right now on your own, because you have all the information to do it and you'll learn so much better. So my advice is right now, stop video and just do these problems and then check your answer. All right? So I want you to do that. Okay, so before you stop it though, of course you need to know what the problem is. So the question is here, one student listed her fastest speed as, so let's just say 114 miles per hour. So now that you know that, we can do the problem and you should stop the video. All right, so what do we want to do here? Well, we want to translate that value. The basic idea is to translate that value into a z and then get some area here. So that's what we're going to do. So 100, so how are we going to do this? Z is equal to 114 miles per hour minus, here's our average up here and our standard deviation, so minus 90 divided by 24. And that's just 1. So this is a very easy problem. So 0, 1, 2, and 3, negative 1, negative 2, and negative 3. So now we're going to just line it up right here. Z equals 1. On our miles per hour axis, we have 90 in the middle, and this is where 114 is. So we just want this area faster right here. So how are we going to find that? Well, we know between 1 and negative 1, we should know this without even looking at the table, is 68%. We know the area of the whole curve is 100, so these two tails together would be 32, which means this area right here would be 16%, and this area would be 16%. So that's our answer, 16%. Now, it says, what percentile is she in? Percentile is the same as asking what percent of the class drove slower, so it's all the area below. Percentile is area below the value. That means to the left of the value. So it's easy to see that if 16 are above, then 84 are below. So we have 68% plus 16%, which is 84%. And that's the answer there. All right, now let's just do one more simple one. What percent of the class never drove above, let's just pick a really easy one, 90. Okay? So here we have the normal curve. And 90 is in the middle. So now you can see that we're just interested in this area. So it's pretty obvious that the answer is going to be 50%. But let's say you weren't paying, you just were trying to use our method and weren't really thinking about it. Would it even work? What would you do? So you'd say, okay, Z equals our value, which is 90, minus the average over the standard deviation, and of course you get 0. So then you could look 0 up on the table, and you're going to get 0 area, right? 0 area. So it would certainly work. There's no middle area, so each tail's 50%, so it would work. And this is the 50%. It's the same thing as the 50th percentile. Okay, let's look at the last question here. It says, if the fastest I've ever driven is 0.5 standard deviations below the average, say below average, then what's my fastest speed? Well, this tells you what to do. 0.5 times the standard deviation, which is 24 miles per hour, right? And it's going to be below the average, which is 90 miles per hour. So that's just 12 miles per hour below 90, so that's 78 miles per hour. All right, let's turn the page now, and let's look at this next problem where we don't have a normal distribution. So when you don't have data that even approximately follows the normal curve, what do? Well, you can't just use the average and the standard deviation. They're not adequate summaries of the data. So what you can do, though, is you'll need more information, and this is the same problem, this problem we did on page 19. It's the same problem we did back in chapter 3, I think it was. And so we can still use percentiles, but the average and the standard deviation won't give them to us. So we already calculated the areas. These are just rectangles of all these blocks. We said, okay, this one is 0.5 high. all these are 1 high. I'm just looking at this axis here. This is 2.5, and this is 2. All right, so we got 25% here. 10 times 1 is 10%, 10%, and 10%. This is 25% and 20%, and it adds up to 100. So now it says, what scores correspond to the following percentiles? And don't make this mistake. 70th percentile does not correspond to 70. What does it mean? You want to find the value that divide. What do you want to do? Let's just write it down here to be clear. We want, when you're asking for the particular percentile, you're going to want to find this final score, or find the value here, the final score, that divides the histogram so that 70%, right, of the area, the 70th percentile, 70% of the area of the histogram is to the left, below. And that means, of course, 30% to the right. So we can do that, and here's 30% to the right, and here's 70% to the left, and that's the 70th percentile. So our answer is a final score of 80. All right, so let's do the next one, B. B would be what? What do we want? We want it's the 35th percentile, so 35% of the area is to the left, and 65% would be to the right. So 35%, you see how right here it divides into 30% below and 65% to the right. So that is 60. Now how about this one? What's the median? Well, the median is the 50th percentile. Divides the histogram. We'll do the same thing. You want 50% of the area to the left. And 50% to the right. Okay, so what value does that? And please don't answer 50, because that doesn't. That's the 25th percentile. So let's see. So we go 25, 35, 45. 70 is the 45th percentile. So we want 5 more percent. We want to cut into this block and get 5% out of here. And this 2.5 says that each unit will give us 2.5%. So if we go over to 71, we get 2.5. And if we go over another to 72, another unit, we'll get the 5%. So right here at 72 is the median. That is the median. So we can write that down. It's 72 is our answer. All right, let's go to the next page. Okay, so when the data does follow the normal curve, all you need is 2 statistics, the average and the standard deviation. So let's look at this example about how many hours of sleep students reported getting at night. And we had about an average of about 70 and a standard deviation actually of almost exactly 1. So a student who sleeps only 5 hours, that's the value, is at what percentile? So nothing new here. We're just going from the value to the z-score to the percentile, which is just the area on here. And all we really have to do here, once we get a z-score, we can place it on there. So we just want to convert the value to a z-score as usual. So this is a super easy one. 5 hours minus 7 hours over 1, we have -2. So we're right here. Here's 0, -1, -2. So that is where 5 is. So now between -2 and +2, we know there's approximately 95% of the data, so that leaves 5% on the tails. So we know this area right here, the area below 5, so 7, that's 5. The area below that is 2.5%. So 2.5th percentile. All right, how about the next example? The next example is going in the other direction. It's giving us a percentile. So it's giving us the percentile. It's going this way. Giving us the percentile, which is just a placement on the curve, and asking us to get from that a z and then a value. So what do we want to do? We want to start by, instead of converting the value to a z, we want to start by convert the percentile. To a z. So how are we going to do that? Let's think about it. All right, so right here at 0, we know what percentile is that. That's the 50th percentile. We know that. So we want the 60th percentile. So that's just going to be 10% more area, right? Just 10% over. So just 10% on this side. So let's do that. And that's the 60th. All right, now we want to get a z-score. We want to know what z that is right there. So we need a middle area. So if it's 10% on one side, we want to draw it 10% on the other. That'll give us 20% in the middle. Between the 60th, 10% this way would be the 40th. So we have this middle area of 20%. So we're going to convert to a z-score by finding the middle area. And then looking up the corresponding z on the table. All right? So we've got the middle area of 20%, and all we have to do is look up 20% on the table and see what it's between, what z it's between. Okay, so let's do that. And here's our table. So 20%, this is the middle area. All right, so we have 19.74. It corresponds to a z-score of 0.25. So that means that we've got our z-scores here of 0.25 right here. 0.25 and -0.25. That's the z-score. Okay? Now, which one is it? Is it 0.25 or -0.25? Well, it's above average, so it has to be 0.25. So here we got this middle area of 20%, and from that we get z equals 0.25. So now we just have to get the value. So let's just look here. Let's just remember what we're doing. So 0 lines up with, what's our average? 7. These are hours. So now we're going to say 7. We want this, and we want this. So we want, this is 0.25 above the average. But 0.25 what? Well, in this case, standard deviations, but the standard deviation is 1 here. So we get 7.25 hours. And that's our answer. The 40th percentile would be what? So this is the 60th percentile. This one's the 40th. And you see how it would just be 7 minus 0.25 times the standard deviation. So this would equal what? 6.75 hours. That would be the 40th. And you see how these add up to 100. They have the same z-scores, just opposite signs. So you start at the average and go up. And here you start by 0.25, and here you start at the average and go down. So that's the idea. Now, so let's try the next page. Why don't you pause it and let's see. Let me give you some information, and you can try this on your own. Let's just first make sure everything, all the information is here. Okay, so it's the same example, same type of example. Here you have an average 134, a standard deviation of 24, and it says what weight corresponds to the 15th percentile. How much does she weigh if only, 15%. There's some typos here. Let's just cross those off and write 85. 85th percentile means 85 less. 10th percentile means 10% less. Okay, so just what you should do right here is pause the video, stop it, and try these on your own. I'm just going to say stop video and do it. And then look back and see if you get the right answer. Okay, so let's just do this now, 15%. So we're going to just find the middle area. So we start with the curve, and we're going to get the middle area here from 15%. So what is our middle area? That's what we have to do. Because then when we get the middle area, we can get the z. All right, so here, right here, 0 corresponds to 50th, and we want 15%, that's way down here, 15% below, so down that way, so that's the 15th, and now we want to find this z-score right here. How do we do it? Well, what's our middle area? From this part is 35%, between 50 and 15, 35%. 50 minus 15 is 35, so we're just going to double that to get the middle area, 35 here, and so we have a middle area is 70%. Okay, once we know that, and by the way, so you go 35 below here, 35 above here, would give us the 85th, and check to see that those add to 100, and they do. So that's going to be between negative z and positive z. So you want to look up 70%. Look up 70% there. And when you do that, you get a z in the table. It's going to be a little bit bigger than 1. 68 would be 1. I got 1.05. Now be careful here. That means this is 1.05, and this is negative 1.05. Below average, so we need to put that negative in there. All right, so now let's just see what we're doing here. In the middle is 134. So to get our value, what do we want to do to get the value? We're going to start at this average, 134. And then what are we going to add? 1.05. But not pounds. 1.05 what? Standard deviations. That's the standard deviation. So it's 1.05 times 24 pounds. If you put the units in, you can see what you're doing here, because we want to end up with pounds. And if you add those together, we get, but look what I did, plus. I want to go minus, because I'm the 15th percentile. So it's plus a negative, a minus. So I end up with 108.8 pounds. And to guard against what I just did, match them up here. Make sure you're right. This, we want net, the 15th percentile is below 134. Now, what about the 85th percentile? Well, that's going to be right there. So that would be 134 plus 1.05, but not pounds, 1.05 standard deviations. So that's going to equal 159.2. It's the same picture, okay? So you put that in 159.2. So I want you to note that, watch, the 15th plus the 85th percentiles is equal to 100, all right? So it's the same middle area. Same middle area. One's 35% above average and the other's 35% below. So it's the same middle area. So the same z-scores in absolute value, but opposite signs. All right, now we can do the last one, and let's just do it really quickly. Okay, so what? So right away we need the middle area. All right, so 10% is there. That's the 10th percentile. 50th in the middle, so that's 40%. 40% here, that's going to be 10th and 90th, right? This is a z-score of 0. So what do we want? Our middle area is 80. Look up 80%, and you get 1.3 rounded and negative 1.3. So what does that tell us? You can just look here. You have 134 in the middle. So this is going to be 134. We want 10%, but here is 90. So let's just do both of them. So this is 134 plus 1.3 times 24. And this right here is going to be 134 minus 1.3 times 24. That's the standard deviation. Okay, so if we do these out, we get this right here is 102.8, and this right here is 165.2. So this is the 90th, and that's the 10th percentile. So I just want to remind you all now to read the summaries. Read everything. They're the best way to study for the exam. Read. And I just want to, here's the procedure we've just been doing. If the data follows a normal curve, you'll always, to get from a value to a percentile, you have to go through a z-score. So if you want to go from the percentile to the value, you have to go this direction. All right, and that's it. We'll do chapter 6 next time. Bye.